and I'm here to kick off our afternoon session of speakers. And here with me, I have Dr. Michelle Girak from JPL, and she's going to give you guys a pretty awesome presentation. So without further ado, I'll let you take it away.
Oh, thanks, you guys. High bar set. Oh, now I got to make it awesome. So, Michelle Girak from NASA JPL. I am the Associate Scientist for the Earth Science and Technology Directorate. The unspoken, typically when people hear JPL, at least all of you know, we do Earth. But generally when we get a lot of high-profile people that come in, they really only think planetary. So I think this is first step. You guys know we do Earth, and I'm going to show you some awesome Earth examples. We sort of like to think about, let's say you went back 20 years and you came to JPL. We talk about a lot of amazing scientific discovery enabled by technological innovations, right? We dare mighty things. But we realize there's a lot of use that can happen with that data. So how do we now translate that Earth information to action? So we've really been taking a stronger stance with respect to that. However, we realize we're still missing that last mile, right? When I first had talked to Steve, I actually was completely unaware there was a GIS day. So that just illustrates we still have some work to do, but the point being we're going in that direction, but we need help from all of you in finding out what in fact are your needs so that we can try and provide the right type of information to actually enable societal benefit. So we do a lot of different Earth themes, but we like to try and tackle 6 particular ones. That's not to say that we're not doing other things, but we know that we have strong expertise in a lot of satellite missions focused around 6 key areas. And that's greenhouse gas, air quality, sea level rise, freshwater availability, so that's the quantity and quality of water, biodiversity, I'm aquatic, so it's aquatic biodiversity, but you can think aquatic and terrestrial, as well as extreme events, so natural hazards. So in a nutshell, how do we take that Earth science information to action? So typically, again, for the people that don't know, we do a lot of Earth science. This is sort of hopefully makes the message. There's a lot of different satellites out there right now collecting Earth observations. Of that NASA fleet, that's what you're seeing here, the entire NASA Earth science fleet, the things that you have marked in sort of those little boxes that are sort of purple or pink that are also dotted, those are JPL missions or JPL contributed instruments. So overall, we're about half of the entire NASA Earth Science portfolio. The other half is largely Goddard, which is our sister center on the East Coast. So between us and Goddard, we really sort of run the Earth show, if you will. So I said we're sort of going towards how do we take that information to action, but we feel we have 2 really stellar case studies that we can look at already. But we can obviously always do more, and we want to expand it with all those thematic areas I talked about. But one of those like gold star standards we feel that we're doing a lot in already is sea level rise. So I'm sort of going to take you through this ARC series, if you will. So we have a lot of different observations, right? So you have obviously the long-term sea level rise trend that we have that's been a great partnership with the French Space Agency, CNES. So a lot of these long-term records are really enabled by partnerships. Without those, we really can't have such long records. So this is a fruitful partnership that we do have with the French Space Agency, again, since 1992 with the launch of Topex Poseidon that continued on with the JASON series. And it's telling us, obviously, globally, how sea level is changing. And you can look at those small undulations in the actual time series itself, and we can use other Earth satellite observations to figure out how, in fact, what do those wiggles correspond to, right? So back in the 2009 to 2011 time period, there was, an El Nino Southern Oscillation. Carmen actually had a fabulous paper that showed, there was this dip that happened, as you see there, sort of like a significant dip, and you're like, oh my gosh, is sea level going down? No, what had just happened from the GRACE series that you see here, GRACE and then GRACE FO, a lot of the water, specifically on Australia, had not yet made its way into the ocean. So it was just literally on land. So it shows the sort of displacement of water between land as well as the ocean, as well as looking at sort of how much ice is contributing to sea level rise from the glaciers, right, from the ice sheets that happen in Greenland and Antarctica, and you're seeing overall the trend in the ice mass loss for Greenland there, but we have the same type of trend with respect to Antarctica. And then you have, again, we always like to do the next, latest, and greatest, right, cool technological innovations, and that's SWOT, surface water ocean topography. So this thing's unprecedented, just have to say. We're still sort of learning a lot of different things it can be doing. We obviously set requirements for it, but it's like far achieving beyond what we ever thought. So this, what's so cool about it, it does continue this amazing sea level record, providing even more granular information of the ocean. So it gets even smaller scale variations that you're seeing. This is a model simulation, this isn't the real data, but it looks very similar. But it also provides the closest observations we've ever gotten with respect to the coast. Coast is where the majority of people live, thus the importance of this type of mission. Beyond that, it provides the first ever spaceborne observation of terrestrial sort of water. Not only water extent, how much it changes, because we have that right now with optical, but how much that water surface elevation is changing. And if you couple that with the slope, you can actually get freshwater discharge or stream flow estimates, which is sort of what we're working towards now. So unprecedented, groundbreaking for, you'll hear me say unprecedented a lot. It's something that I think is just our tagline. But with respect to terrestrial, coastal, and then open ocean for SWAT. But again, really exciting, just want to talk about that. All these observations by themselves, I would say, period, can provide great actionable information. But if you start sort of combining that with models, so what you're seeing here in the top, this is a model that's sort of a consortium for the MIT GCM. JPL contributes a significant portion to that, but a lot of sort of the academic institution does as well. Again, this consortium. It provides the most realistic ocean state estimation. So basically, it's a data assimilative model. It's taking in all that satellite information to provide this realistic scenario of what's currently happening to date and what has happened in the past in the ocean. We have the same sort of principle with respect to the ice sheets. That's that model there in the middle, ISSM. It also allows you to sort of look at projections of how things could change. And if you couple the observations with those models, you can actually get now at sea level projections or predictions, right? Again, that can provide information by itself. But take it all together, right? And we're doing decision support already at various scales. So local with respect to California, right? Middle being more federal, so the agents, not federal, agency, US driven. And then the bottom also helping with respect to the international. So the small island nations, specifically for Tuvalu here, asked for a report, and this was part of the UN Rising Nations Initiative. But a lot of other island nations also in the Western Tropical Pacific have asked for similar information, and the sea level team is providing that. So again, just a nice arc from observations to models to inform sort of that decision support. And the other one being greenhouse gas mitigation. So we have a lot of different observations, again, that are looking at global CO2, as well as those localized point sources of CO2 and methane emissions with EMIT. So EMIT is a new mission that's now in the International Space Station. If you guys have heard about it, it looks at minerals, but it's an imaging spectrometer, so we know it can do a plethora of other things here, specifically with respect to greenhouse gas. So again, period, we can do a lot with this great information. Actually, EMIT, as well as our airborne sensors, have been looking at, emissions associated with Aliso Canyon, as well as Chiquita Canyon. We have observations. I had to take it out because it's not publicly available yet, but the data is publicly available if you know how to translate it to methane right now. But aside, we have a lot of observations that can help inform as well. But again, our job is not to make the policy or inform, it's to provide the data that then you can all take and do something with. But same story, observations, pair it with models. These are various models on the bottom that feed into this overarching sort of architecture called the Carbon Monitoring System, or CMS Flux. So you have, a land surface ecosystem model, a more extreme or natural hazard event, so MOMOCHEM. Then you have the ocean component, pair that with winds, it all goes into this larger scale model that looks at carbon across all the different biomes and how that then informs decision support. So the top there, we can actually now, using that model with those observations, get at global carbon stock take by country, right? So you can see per year, whatever season, how in fact maybe these countries are achieving or not what they've stated in their policies. Again, our job is just to provide the data, but that's one component. You can also think of, there's now a US Greenhouse Gas Information Center that you see on the bottom there, and all this data is also feeding into that as to how the US specifically is proceeding or working towards their goals. So I sort of talked about different scales, right? Local, more US-centric to global, but now bringing it back to LA County, right? So specific. So what you're seeing and what we're going to go through now is sort of a racking and stacking of all the different observations we've had and all different types of more scientific, I would say, case studies that sort of illustrate how some of this data could be used. But a request to you all, we're providing a lot of science, but what are your needs, right? And then we can curtail and actually develop products that you all need and want. But these are just a few examples to showcase some of the things that we have been doing sort of for LA, and specifically LA County. So sea level rise. If you recall, there was that local, more regional, and then global perspective of our decision support for sea level. This is actually information pulled directly from that more California-centric. So what you can see, I think we all know this, right? Within California, though, specifically LA, sea level is rising. It's been rising over the past 50 years. And up into about the next 3 decades, we're going to get sea level rise increases of about 6 inches. Same thing, you can also look at flooding and inundation, the number of high flood tide events that are going to happen. And realistically, sorry, I can't really go there and point out things, but that little sort of pocket that's pulled up, you can sort of see overall where we stand to date with respect to high tide flooding events, and you can see the projections going forward. So basically, Los Angeles could experience 20 days of minor high tide flooding by 2050 and over 250 days by 2100, right? So it's very significant in the impacts associated with that. So talking about water, right? So how much water is there and what's the quality of the water? This is just showing all the different sort of sources of the water that reach us, right? Whether it's actually imported, local surface, or recycled, as well as the groundwater consumption we have. And to assess that, we have missions like GRACE and GRACE FO and coming up GRACE Continuity that look at this. And this shows you specifically for the entire state of California, of which LA is in there, showing you how this particular missions has looked at sort of the groundwater supply within the area. And what you're seeing there is it's showing you the changes over time, but then you see the time series for that outlined yellow region. And surprise, no surprise, right? We continuously are decreasing with respect to our groundwater supply. If we get some blippets here and there with respect to all those atmospheric rivers that come through, but overall we're still in a downward trend. But so how do we use these types of observations to help inform as well? Aside from groundwater, we can also look at snow, right? That's another source for us. So what you're seeing here, you're seeing 2 different types of line, but overall, one's more observations, one's a model. So blue is the observations, red is the model. But what to illustrate, overall, it seems pretty, stationary for the most part until about the, 2010 time period where we're getting a significant reduction that's occurring. So I think we all know this, our snow water equivalent is decreasing. It's also decreasing in extent, and the projections are pretty bleak, right? So if you look at sort of the 2025 to 2050 time period, it's showing our overall snow water equivalent, that's what the SWE stands for, loss of about 20%, more than what it already is, with about a 50% decrease in the next time period, all the way up to almost 75-80% by 2100. So we need to think of ways in which we can help supply water to our citizens. And satellite observations can help us sort of make those management decisions. Then secondary, I know there was some interest expressed with respect to synthetic aperture radar, and we have some upcoming missions that will launch hopefully in February or early 2025 called NISAR. If you have not heard about it, I'll show you in the end. But it can give us a lot of different information, one of which, similar to GRACE, which is telling us about the water, this provides a different picture with respect to how much the ground is uplifting or sinking with respect to sort of subsidence. So if we're pumping it out, or if it's just like changes with respect to sort of our, geology that we have within California. But this was a specific airborne campaign, the image on the left that you see there, from UAV SAR, looking at the California aqueduct subsidence that happened in this 2013 to 2016 time period, with blue indicates more serious subsidence on the order of about 30 inches or more. We're on the right-hand side that you see there. This is from INSAR, so a different type of SAR measurement. And what you're seeing for the entire state, I'm sorry, I couldn't really pull out LA County, but you can see overall throughout the state where you're seeing significant decreases. Again, the blue versus red being more uplift. So again, we can use these types of observations to help as well. And with NISAR coming online, which will basically give us about every 12 days, and you could probably maybe do 6 days, it will provide this type of observation globally. And still looking at SAR, so there was a massive oil spill in Huntington Beach area, and there was an airborne campaign, again, using UAV SAR that actually went out and assessed sort of the extent, if you will, and severity with respect to this oil spill. So what you're seeing on top, the oil is in fact the sort of dampened darker. So basically what this instrument does, it actually is an active sensor, so it sends a signal, and what's received back at, if there's in fact something, it sort of damps the capillary waves of the ocean surface, so that's that darkness that you're getting. So that is in fact oil. It could also be biogenic, slicks, all kinds of things, but we know in fact it was oil. And then this is showing you with respect to some higher level processing that they've done, where in fact the oil and the characterizations of it and perhaps the thickness that can be done as well. So again, another instance of what perhaps NISAR, in addition to our airborne capabilities, can do when there's these horrible, episodic events that happen. I feel I'm just giving you doom and gloom, but it's just showing you overall a lot of the things that we have, horrible problems that happen. We have some excellent assets that can help with sort of hopefully planning stages as well as the operations, but the impact as well. So sort of looking at 3 different phases, but yeah, more doom and gloom. So what's happening in Palos Verdes, right? Also synthetic aperture radar. So we already know that this is what it looks like. And on the right there, what you're seeing in the blue is a level of land sort of displacement or sinking again associated with that horrific event. And you can sort of see it at different points. So, sorry, you see these little like orange diamonds, and what you're seeing here is the 4 plots associated with it. This is showing sort of the land surface displacement, or how much land is being lost. And what you're seeing in those like blue spikes below is the atmospheric river precipitation content. So overall, it already was sort of slinking off, right? But the atmospheric rivers that we've been getting, since we've been getting so many year to year to year, has actually been accelerating sort of this sloughing off of the land. So again, these types of observations, this one was written up, I think, in a recent press highlight. More doom and gloom. No, I'm kidding. So I have some EcoStress people here, and hopefully I do a service. EcoStress is another instrument that we have on the International Space Station. It really was put up there to assess plant health, if you will, and the implications with respect to water management for irrigation and agriculture. But it is a thermal sensor, so it provides, if you guys just looked at this, how I always see it, it almost seems like a great Google Maps, right? It's showing us exactly sort of our infrastructure that we have with respect to streets. If you went even finer, you can see sidewalks. But overall for LA, it illustrates sort of how in these extreme urban heat events that we have. This is one that we had back in September of 2022, but the same happened for 2023 and 2024. When we get these horrible extreme heat events, you can actually use instruments like EcoStress to assess, how this heat is being distributed across our county, where you can see, in fact, the red being obviously hotter versus cooler occurring along the coast. This was a nighttime temperature capture, so you're probably like, oh man, I should live on the coast. Well, yes, but you're getting a lot of marine boundary layers, so it's also sort of compensating and sort of riddling out the signal, but overall it was hot everywhere. And you can actually pick out really sort of fine scale features. So this little plume that you're seeing here is real. That's associated with a wastewater treatment plant. So, right, they take in all the ocean water, they turn it through to cool down their instruments, and then they dump out sort of this water that's been heated, as well as with the effluents associated with it. So that was really cool to me. I'm, again, oceanographer. So there's that, but then you see little pockets associated with obviously urban or industrial. So we can use this to look at the scientific interest, but you can also now start using the same information for more environmental justice. So this was a study that was done by an individual at JPL, where they basically took the EcoStress temperature maps, overlaid it with the historic red line districts, and what you can see is the areas where are red, which are more of the lower middle income, are in fact where you're getting elevated temperatures, comparatively speaking to the areas that are more affluent being green. And why? Why are there differences? Well, as you then start overlaying different satellite observations, this being more optical, you can see sort of a stark difference. And what do you guys see? What's the main difference between those 2 pictures? You're right, vegetation, right? So you take Pasadena, significant vegetation, versus Boyle Heights. So this can also then start helping as to what are types of mitigation activities that we can ensure, because clearly these urban heat events aren't going away. They possibly are going to increase in frequency and intensity. So what are things we could be doing now? So planting more trees, also laying down different reflective coating perhaps on asphalt. So what you're seeing here, this is actually a scene captured, all of this is airborne data. This was an image that was captured over obviously JPL at Dedina, and even that you can see the small scale granularity, right, between again, a more affluent versus a more urbanly developed region just around our lab. So this particular scene was from HITES, which is again our airborne component of EcoStress. And you see sort of here these two streets versus these two streets. That's the point difference. These are where in fact that reflective coating was laid down upon the asphalt versus an area that was not. And you basically see between a 5 to 10 degree Celsius difference, not Fahrenheit, Celsius difference. Right, so clearly things like this can also help. And there's been several individuals that have now taken this type of information, gone federal, gotten some earmarks to do this with Arizona and other states. And this was a recent press release as well. So our children, right, the youth of science, what we need to keep going. One of those urban heat events, this is in, Sunnybray Elementary School. And they, granted, the children, I have small children, they are not out during these time periods, they keep them inside. But a lot of their playgrounds look exactly like this. I was actually complaining in my school. I was like, why do you have asphalt exactly where all the kids play during all times of day? And you have them starting school earlier and earlier every year. Aside, a lot of asphalt, 160 degree Fahrenheit. I mean, this is extreme, right? So again, what could they be doing with respect to this to make sure our youth and the future of us actually have conditions that they can live in and play in, right? We should have them outside, not be inside all the time. And last but not least, air quality. So overall, we have a lot of different air quality instruments that we can be looking at. This is maybe a positive. Air quality has improved, you guys. So I know, yay! From 2010 to 2019, you basically see, hopefully, that there has been a significant reduction overall with respect. So that's cool. But now here's the doom and gloom. No, I'm kidding. I do it. I love Amazon, so I'm ordering things, I want it as quick as it can be, but we've basically noticed, this is a graphic illustrating areas in which, or zip codes that have significant warehouses versus zip codes that do not. So take, in fact, Rancho Cucamonga on top versus Pasadena below. And what you're seeing is areas in which have more of these larger warehouses, like Amazon and many others, are experiencing worse air pollution conditions than those that do not. And then you also think about the trucks with respect to the transport. So yes, you see it on the streets and the interstates, you would have that anyways, but if you're getting a lot more traffic with respect to all the goods that we're procuring, but again, we have instruments that can monitor this, and we have future missions that are really going to be coupling these types of things. So I mentioned NISAR. So this is our, we have that fleet. I showed you, we got tons of observations up there, and we're always planning the next 10 years, right? And we're planning even beyond that. So I'm associated with that mission of that very tail end called surface biology and geology. So, basically we're looking at 2028, 2032, and I'm like, that's so close. It may seem very far for you guys. But we have some missions that are even closer. So NISAR is that massive, again, like SWAT, unprecedented the things it's going to be able to do. It's looking at various different natural hazards, groundwater, the aquifers, all kinds of things. That's hopefully launching in early 2025, so expect good things. Maya is a mission that we have with the Italian Space Agency that will launch in about 2026. And what's really cool about this one, with the air quality things I just talked about, this is the first ever mission that's looking at the air quality and the different sort of species composition of it, but it has epidemiologists actually on the team. So they're basically coupling the health of people, specifically, not premature, but babies. It's like a 9-month cycle, right? So looking at the implications of the areas with respect to sort of childbirth and the conditions that they're facing and the air quality. So it's really, really cool. Then continue on with the amazing sea level record and so on and so forth. And I just want to give one plug. So I mentioned a whole bunch of things, some examples, but realistically, as I said, we know we have a lot of work to do, and we also realize we are maybe not the ones to do it. But we have great information that hopefully can inform you all. So what we need now is more of a conversation, finding out your needs so that we can produce the products to help you all inform and do things, amazing things that you're already doing. So I just want to give a shout out to the 2 booths we have. So I'll be at the booth the rest of the day with respect to sort of more of the overarching earth science, anything you want to learn. We also have a amazing GIS innovation hub at JPL that Carmen Blackwood, apologies, I knew Carmen before, So this is two great collaboration ways that we can sort of work with you all. So this can connect you directly to scientists to do the work, to pass it on, and the Amazing Develop program, if you haven't met some of the amazing individuals, these projects are always fabulous. I have to say, the caliber of students that come out of this is ridiculous. You guys always set a really high bar for me for any other interns that I'm like, this intern didn't produce a paper, what is this? But develop students, amazing. And again, that's a coupling that we have to have a stakeholder, you have to have sort of a societal need. And again, these are just two ways, so come talk to us a little bit more, but that's it. Sorry, I could have gone on and on. So thank you for keeping me to time.
All right, yeah. Dr. Michelle Gurek. That was definitely one of the most informative presentations we've had ever. So thank you. Really do appreciate that. All right, so any questions about the presentation? All right.
So you were talking about like how there needs to be more like coupling of the data that JPL is able to produce and like the needs. And so like obviously these are a couple of ways that it's been happening, but like what is your view of like the overall trajectory that's been happening with like coupling things has been very good? Like what is really still needed?
I would say that's something we're working towards, right? So the good news is JPL has been doing this for at least a little bit of time, making these connections with the Amazing Develop project as well as others, EcoStress being the premier gold standard case that we have for some of those stories. But those have been, I would say, been labors of love by individual science PIs. But what we've been noticing, aside from JPL and the activities we've already been doing, NASA headquarters now also has an invested interest in this. So they put out this Earth Science to Action strategy plan. So NASA headquarters now is fully behind this. How do we take this information for societal benefit? Just to illustrate, this is not only just a JPL thing, but a NASA thing. So I think given that sort of elevated need, because these issues are happening more and more, right? We have all this data. We also need to ensure these missions continue, which requires illustrating to all you all, why are we doing this in the first place, right? So I think that in itself just shows there's a backing behind this. We're scratching the surface, but again, it's that connection that needs to happen. Because we can, a scientist, I can just go off and be like, oh yeah, you guys want this? Here, and I can come to you and be like, here, take this water quality product. And then people will be like, that's not what I need, right? So we need to, it needs to be the conversation now to really have that dialogue to convey what we can do, what you need, and meet in the middle as to those, and then design the next spaceborne observations to meet those needs, right? That it's always that tight coupling. So we're getting there. We started. That's one step, right? Got to get started. Baby steps.
All right, we have time for one more question. Anything from students? No?
I know, put him on the spot.
Yeah, so if no more questions, then I want to thank you very much.
Thank
for
you guys.
And, yeah, and if you check out the tables. All right.
Thanks, you
thank
guys.
All right, and I do have a certificate for you.
Oh, I get a certificate? Oh. Hey now.
Perfect.
Oh, sure. Oh, okay. Like a serious.
Yeah, that one.
Yeah. Like I'll be that individual, whatever works. Oh, perfect. Right on. I didn't go too far over, right? Okay. I really tried. If not, we can be long-winded. So I really tried to cut that slide.